Okay, so I just want to do a quick reminder of our rules from our previous videos. Again, exponent of 1, if we have any term that does not have an exponent on it, it can always be written as that term to the power of 1, so a is the same thing as a to the first. The exponent of 0, if we have a to the 0 power, that's the same thing as 1. Again, anything raised to the 0 power is always 1. If we're multiplying two terms together, they have the same base, in this case both a, we can take and add our exponents. If we're dividing, then we can take our exponents and subtract them. Again, remembering we're not changing the base on these, we're just messing with the exponent. If we have a negative exponent in the top of a fraction, he really wants to be in the denominator. And the opposite's true. If a negative is in our denominator, he really wants to be in the numerator or the top of our fraction. So we're going to add 3 more rules to our list of rules here. The next one being what we call the power rule, and that says if I have a to the n and I raise it to an additional power of m, I'm actually going to take those two exponents and again I'm going to multiply them together. Notice again, I'm not changing my base number, I'm only messing with my exponents. So again, if I have n raised to an additional power, then we take our powers, our exponents, and multiply them. So for example, if I have x to the third and I raise that to the 7th, this would be x to the 3 times 7, which would be x to the 21st. And you don't have to write that out all the way every time. I just want you to see again that power to a power, we multiply them together to get the 21. Now we have the power of a product. Now what that means is that if I have more than one term inside of a parentheses, like this one where we have a and b both being raised to the nth power, it's kind of like a distribution rule, but I want you to make sure you understand that I'm not distributing like a number in there, I'm distributing an exponent. So this n would go to the a as well as to the b, and this would be a to the nth power and b to the nth power. Now in its most simplicity, we would be something like x, y to the third, and again this 3 would be given to both the x and the y, so this would be x to the third, then y to the third. Now one of the things that people tend to make a mistake on this section is when we have a number in there and we want to kind of keep the 2 and the x together, but I want you to remember that the 2 and x don't have to stay together. It's multiplication. They can be separated. In fact, they need to be thought of as 2 different pieces, because this power of 2 needs to go to the 2 as well as to the x, and so this is really saying 2 squared and x squared. Now notice that I'm not saying 2 times 2. I'm saying 2 squared, or I would be saying 3 squared. Remember, this is going in as an exponent, not as a multiplication. Now it just happens to be that yes, 2 squared is going to be 4, because you are doing 2 times 2 because you're squaring the number. But I want you to realize when you distribute that exponent to a full number, you are distributing an exponent to that number, not multiplying by that number. And the quotient rule is very similar to the product rule here, and that's if instead of multiplying, we are dividing 2 terms together and raising that to a power. And again, basically this n means that it goes to both the a and the b, so this would be a to the n over b to the n. So for example, if I have 2 thirds raised to the third power, this power of 3 is going to both the 2 and the 3. And again, remember that this is a power or an exponent. This isn't multiplying by 3. So this is going to be 2 to the third power over 3 to the third power. Well, 2 to the third power means I'm multiplying 2 times itself 3 times. So 2 times 2 times 2. And 2 times 2 times 2 is going to give me 8. Same thing with the 3 to the third power. I'm multiplying 3 times itself. 3 times 3 times 3, and that is going to give me 27. So 2 divided by 3 to the third power is the same thing as 8 over 27. Okay, so for our first example, we have 4, and then in parentheses, 5x to the fourth squared. Now what I want you to understand is this squared, or this exponent that we have here, does not go to the 4 because he's not inside the parentheses. So he only goes to the 5 and the x to the fourth. And I'm going to do this in a lot of steps, but there are definitely some places where you can skip around if you understand what I'm doing. But I like to show every step when we're going through this the first time. So we're going to have 4, and then times, again, remember we're giving that 5 the power, or the exponent of 2. And then we also have x to the fourth, which we're raising to an additional power of 2. Now, we still got our 4. We're not messing with him yet because remember, exponents always come before multiplication. So we do want to go ahead and say, well, 5 squared, that's going to give us 25. And then remember, we just went over this, a power to a power. That's one of our new rules, and that is a multiplication. So when we multiply 4 times 2, that's going to give us x to the 8th. And we only have one more thing to do to get this in its simplest form, and that's we need to go ahead and multiply our 4 times our 25. And 4 times 25 is going to give us 100, x to the 8th power, and this would be the answer we would want to put in our homework. But again, remember that the power only goes to the things that are inside the parentheses. So if you have a number outside, he doesn't get raised to the power that everybody inside the parentheses gets raised. Okay, so for our second example, we have 3 times 4m n cubed raised to the 0 power. Now remember, we love that raising something to the 0 power. That means because everything inside of this parentheses, that whole statement is being raised to the 0 power, which is automatically the number 1. But notice you've got this 3 sitting out here, so he's not being raised to the 0 power. So we're going to bring him down and say 3 times 1, and that's going to give us 3. Again, it's really important with that 0 power to remember that the number in front, or the number outside of the parentheses, is going to stay, and you're going to be multiplying that times 1 about whatever, so that's the whatever that's in that parentheses to the 0 power. Okay, so for our next example, we have 2 times 3x to the negative 2 y raised to the negative 3. So again, just like that very first one we did, we've got an exponent here outside of our parentheses, and I know he's negative, but we're going to take care of the negative exponent in just a minute. We're going to take this negative 3 and we're going to give that exponent to all 3 of the pieces inside of that parentheses, the 3, the x, and the y. Notice that our 2 is just going to stay out here for right now. So he's 2. That's going to be 3 to the negative 2. We're going to have x to the negative 2. Oops, I'm so sorry. That should be a 3 to the negative 3. And then we have y to the negative 3. Now, I don't want to mess with this 3 to the negative 3 right now because, again, he's got a negative exponent, so it means that he's not where he wants to be. So we're just going to leave him alone for right now and say we have 2, 3 to the negative 3. Again, we have a power to a power. We want to go ahead and multiply that, and it's really important that you do that multiplication before we start moving stuff around, because you'll notice here when you do negative times a negative, that's going to make that x to the positive 6. So he's actually perfectly fine in the top of our fraction, so we don't want to move him. And then we have our y to the negative 3. So now what we're going to do is now we need to get rid of all of these negative exponents. Okay, so draw yourself a fraction bar, and we're going to go one piece at a time. So looking at the 2, remember his exponent here is 1. That's a positive 1, so he's perfectly fine in the top of the fraction, so he's going to stay up here at the top as a 2. Now, 3 to the negative 3, he's got that negative exponent, so he is not okay. He doesn't like being in the top of the fraction. He wants to move here to the bottom, so that would be 3 to the 3rd power. X to the 6th, that's perfectly fine. He's perfectly happy where he is, so he's going to stay up in the top of our fraction, x to the 6th, right next to our 2. And then our y to the negative 3, again, he's got that negative exponent. He doesn't like being in the top of the fraction. He really wants to be on the bottom. So we're going to move him down there with that 3. He becomes y to the positive 3. Now the only thing we have to do to finish this problem out is we do need to say, well, what is 3 cubed? So this is 2 x to the 6th. And remember, 3 cubed is not 3 times 3. It's 3 times 3 times 3. It's 3 times itself 3 times, which is going to give us 27 y to the 3rd power. And this would be our final answer. Okay, so for our 4th example here, we've got 3x to the 3rd over y being raised to the 2nd power. And basically, again, we've got multiple things inside of our parentheses being raised to an additional power of 2. So everybody in the parentheses is going to get this power of 2, the 3, the x cubed, and the y. And again, I'm going to write this out in phases, but you can definitely skip some steps if you want to. So this would be 3 squared, x to the 3rd squared, over y squared. Now, everybody's happy. Everybody has a positive exponent, so we're not moving anything around. We can go ahead and say, well, 3 squared is 3 times 3, which is 9. X cubed squared, remember our rule says that we take these two guys and we multiply them together, so that's going to give us x to the 6th over y squared. And that's as far as we go. Everybody's happy. I only have one x and one y. I can't reduce anything, so we're done.